Okay. Hey, everybody. Rob, do you mind jumping on video?
Hey.
Thank you so much for joining today. My name is Andrew Farah. I'm one of the co-founders and CEO of Density. Today, I thought it'd be fun to bring the person who leads product and also one of my co-founders, Rob Grazioli, to walk you through our latest launch, which is a product called Density Open Area, designed to measure open space. You may have seen some of this on our website and some of the launch material, but we thought it would be interesting to actually show you how the technology works and to do a live demo on webinar. Now, I want to caveat that live demos often cause chaos, so you'll have to bear with us, but I think we've got some cool stuff to show you. So there's like 3 sections. First, Rob's going to walk you through sort of a quick overview of Open Area, how the technology works, explain to you why we designed the system, who the typical users are, and what we think this will unlock. And then I'm going to show you like a live system. So I've installed one above me, and I'm going to show you how the system works live. And then the last section is we're going to show you really briefly like all this data rolling into analytics. And along the way, if you ask questions in the Q&A, I will bring them up during, or we can cover at the end. So I think in the there's a QA button down at the bottom right. If you just click that and toss in any questions that you have along the way, I'll make sure to pull them in. And otherwise, just really appreciate you all spending a little bit of your morning or afternoon with us. So with that, I'm going to kick it over to Rob.
Cool. Yeah, super stoked as well. Obviously, team's grinding pretty hard. We're really excited to get this out there. So really quickly, this is Open Area. It's about the size of a BLT, pretty thin. If you're familiar with our existing product, it's about the same size in X and Y, although thinner and lighter. It's also this really cool mount kit. So it's super flexible and can mount anywhere. So you can see, you can adhere to any surface here. So it adheres to the ceiling. And in conjunction with our entry sensor, we feel like for the first time, we're really covering an entire space. So a lot of analysts in our field talk about tiers of data. So tier 1, tier 2, tier 3, and we feel like we're finally not just sort of around the perimeter of buildings and giving super accurate count for large bodies of square footage, but instead we're finally looking into the space and giving hyper detailed information as to how people are using it. So it's a powered solution. So it's PoE. So one single plug on the back here, right here. Now that's really for convenience. It can be powered through a wall outlet or directly from the switch, and it's Wi-Fi capable. So it's really quite versatile. It's super easy to set up. We really default to a powered solution because we're sort of infatuated with the set it and forget it methodology. And when we dive into the live demo, I think it'll be a little more clear as to why we think always on is so important. One, just for from a data integrity standpoint. Always on means no data gaps. It also means reduced maintenance costs. You don't have people going in and replacing batteries and replacing sensors. We're also trying to avoid moving sensors around. So we're really trying to create this concept of install it once and play beneath. And yeah, we have some really cool stuff Andrew's going to show you. But like any density product, we're trying to make it as integrated into any environment that we like. This is a hyper stylized office space, but you can just kind of see it on the ceiling here. So designed to blend in, but if you do notice it, we want to make sure it's beautiful. And I think everyone would kind of agree that we've really stayed true to form there. But what's I think particularly interesting about this product is not just the sort of the overhaul of a hardware design, but in reality, the technology, how it works, and how we're using that to our customers' benefit. So I'm gonna do a quick demonstration here. Sitting here is John. He's actually one of our development leads on the project. And you're gonna see another person join us in a second here, but John, this is what the sensor sees. This is all it sees. It's completely anonymous. It creates a point cloud of data by sending signal into the field. And you can see while it's not optical in any way, it's granular enough, whereas we can actually tell the difference between people. We can draw boundaries between people in 3 dimensions, and we can use that to essentially monitor what's going on within a space. This particular sensor is scoped to this desk, but in reality, it's quite a large coverage area, which we'll again demonstrate to you. But I just want to emphasize how cool this is. We internally, we have a strong stance on anonymity. Monitoring without surveillance, we think, is sort of really important, especially in the current climate. It's really easy for companies to, I think, default to, okay, let's install cameras everywhere. And yeah, we've just tried really hard to deliver a solution that gives companies an option. So that's really the focal point of our product.
And if I could just add, one of the really important parts of any scaled sensing system is the data at source. Oftentimes, the concern really isn't whether or not a vendor is a good actor. Most vendors are very well-intentioned and good actors. The concern is that if you install systems that are optical in nature, you often run the risk of, if that vendor ever gets compromised, what do they have access to? And so we encourage customers generally, and we encourage customers to actually ask us as well, can you show me what your sensor sees? As opposed to just, do you anonymize, but like, can you show me what your sensor actually sees, and is it anonymous at source? There's a lot of marketing around privacy and anonymity. We think that the simplest way to get to the heart of a system is to simply ask, what does it see? We have a couple questions, Rob, if you don't mind me just kind of jumping through those before you keep going.
Yep.
If you can differentiate people, can you track people where people are anonymous? So if you have contiguous coverage, we can measure anonymous humans moving between sensors if you have overlapping coverage. Now, as soon as they disappear from the field of view, meaning they leave the floor, or they go down a set of steps, or they go into a room that's not covered, or they go into an area that's not covered, if they show back up, we can't fingerprint them. And it's a very important part of this, is that employees are deeply concerned about, and legal teams are deeply concerned about the liability around PII. Oftentimes there are different levels of data type, level 1, level 2, level 3 on just sort of the security of it. So while we can track people while they're in field of view, we can't determine age, gender, or ethnicity, and we can't fingerprint them once they leave the FOV. There's a really good question about coverage. So this sensor can be mounted up to 20 feet. You'll find that that's an extraordinarily high install. Most ceiling heights will range anywhere from, in fact, humans are really bad at determining distance and height. So you'll often say, oh, that's like a 20-foot ceiling, when it's really like an 8.5-foot ceiling. But I would say, like, this thing can work everything from, down to about 7 feet, or maybe a little bit lower, all the way up to 20 feet. And depending on how high you go, the more coverage you get. But you can expect, over 1,000 square feet of coverage on the higher end, and in some cases, even larger. All right. I saw the dog walk through the shot. This is a good question. So I do have a dog. I have an English Shepherd. He's awesome. His name's Indiana.
So Andrew, I think they're referring to this particular video here. There's actually a dog that cruises through at one point.
Okay, not my dog. All right. So
yeah.
Maybe you can speak, Rob, to how.
Yeah. So that kind of goes to my earlier point, where in this particular demonstration, the sensor's only monitoring this desk very specifically. So we could broaden that field of view. It was really just for our testing purposes where we narrowed it. You could also see that there's actually someone in the background, whereas this sensor actually would pick them up in reality, and we've just kind of excluded that. So yeah, the dog, there's also someone here kind of hiding. It's kind of a Where's Waldo what else is in the scene. But we're very kind of narrowly focused here.
Yeah.
Yeah.
So a couple other really good questions, which we're actually going to be able to demonstrate live. How accurate is the data point granularity? Can it be used to determine multiple people in an environment? The short answer is yes. The granularity is really remarkable. Each of these little dots that Rob is showing you, and it's a bit pixelated in the Zoom call, but it's a very sharp image, or at least very sharp three-dimensional space with these point clouds. They're granular enough that very small movements get picked up and then get assigned sort of a height value or a depth value or a point in space, so X, Y, and Z. And so what you can see here on the green and the yellow are two distinct people. That's John and Carissa. And we don't know it's John and Carissa because the system is radar based as opposed to camera. But the point is that you'll be able to track multiple people in space live. These are awesome questions. I want to answer all of them, but why don't we keep going, Rob? And then I'm gonna, when we get to the live demo, I think it'll answer some of the questions that people are asking.
Yep, I was just gonna say that. I mean, so you're up, Andrew. Time to talk
really?
about the live demo.
Okay.
Yep, totally. But before we lead into that, what you're about to see is really where we feel there's an incredible amount of innovation in how one manages this product and process, and how they can actually extract insight in a way that's a little more fluid than I think a lot of what the industry is used to. So super excited to talk about this, but the goal really for all this is, fewer sensors, more coverage, keep those project costs low, and make this a really seamless infrastructure to manage. So Andrew, I'm going to stop sharing.
Yeah, that's good. Go ahead. One important note about why we talk about fewer sensors, more coverage. Our objective is to always build systems that are as scalable as possible. So you shouldn't have to deploy tens of thousands of devices in order to make sense of buildings or your portfolio. So this system was explicitly designed to be 4, 5x what existing systems can provide in terms of open area coverage, specifically so that you don't incur the multiple on per sensor cost when you're doing deployment. So if you've ever gone through deployment in a sensor installation, you'll have, you'll essentially have to have some type of person come in and do an installation. We have an entire partner network that facilitates that, but you have a one-time cost for each installation. And that goes obviously to the installer, whoever's doing the hourly work. We want to keep that as low as possible. You should be able to deploy in an ideal world, and we're not there yet, but in 5 years, you install one sensor and you cover an entire floor. Today it's just that we've been able to build something that can do roughly 1,300 square feet. So, all right, let me share my screen. And Rob, please feel free to jump in whenever you have some additional commentary.
My fingers are crossed at the moment, but looks good.
All right, so we have a floor plan here, as you can see, and I'm zoomed out. This is one of the cool things about Open Area is that it actually gives us an opportunity to allow you to import your floor plans. Now we can integrate with an IWMS system. We can pull floor plans from where you currently store them, or you can simply upload them one by one. It's entirely up to you. But as we go through the process of actually just setting these things up, we thought it'd be kind of cool to just make it really easy to play with space. So you see these little blue dots? Those blue dots are me. We have a sensor, which is this device right here. It's got an orientation, which you can see right here. And let me just slide this over a little bit. So you can see this rotation, which we can play with as we see fit, based on how it's installed. This is all actually done in real time. So what you're looking at is me underneath the device talking to you. And then I've got a couch behind me and there's a chair over to my right. So I'm just gonna just go to the couch and sit down. And what you'll notice is in the top right, you see zebra. It should say sorry, I'm kind of moving around, but you see zebra, that number starts to change. And when that number starts to change, it's showing dwell time. So I think the other one is called donkey, which is sort of an interesting name for it. And
Apologize.
you can see these dots as I move from one space to another. So I can get up from the donkey and I can move to zebra, and I can spend as much time as I want in any one location or another. And what's cool is that as I move through the space, it has a sense of where I am within space. So let me pause there before we keep going and just kind of go through some of these questions.
I mean, Andrew, as you're kind of digging through that, I think like what's really crazy and important to emphasize as everyone's kind of going back to the office or resuming, business as usual as best they can. At least as a software developer, I know the first time I do anything, I'm typically wrong. And I think we really wanted to build a product that allowed people to be wrong the first time and not have to go through this arduous sort of sensor configuration process. And you can see really easily, like Andrew could very easily just move that yellow sort of circle there that's bounding that chair anywhere. If you decide to move where that chair goes to better optimize it or remove the chair entirely, you can just see how easy that is. From 3,000 miles away, you can manage your space.
So I'm going to roll through some of these questions because I think they pertain to what we're looking at. So to help end users reserve seats based on utilization, one would need to marry data with your IWMS system. Yeah, so you can, we have a real-time API that we can integrate with many popular IWMS systems. So if you have a room reservation application or you have a desk booking system that you like to use, all of this data is designed to live and inform those systems, which we actually think is a much better, a much better way of interacting with tools than having to just wholly adopt a new system. We are not a closed system. We very much play nicely with other partners. That is actually my dog. But yeah, so the idea is that you can actually start to see utilization on a individual desk by desk level, individual soft seating or space level, and even room, floor, and then building, which I'm going to show you in just one moment. Yeah, so dwell time, I know that I already mentioned that, but dwell time, if I go over to this like particular space and you keep your eye in the top right, you can actually see how I think it's zebra. Oh, it's a donkey is,
you're in donkey.
Is counting up. All of this data then gets rolled up into our analytics tool so you can understand dwell time in a particular space. Hourly entrance counts in a welcome center space. Yes, so the question is, can the device distinguish between entering and exiting the space? The answer is yes, it just depends on your deployment. So if you want entry-based, threshold-based count, you would use our entry sensor. And if you want open area count, then you would use our open area sensor. So it just depends on your space type. We can do either. Wow, there are 40 questions. I'm sorry, 24 questions. Let's see. How do you tune the sensor to see only a specific area of interest? So why don't I actually show you what that actually looks like? I'm just gonna add a few more spaces. The coolest thing about this is how flexible the system is. So what I'm about to show you is gonna be data from actual sensors, but is like, I'm not sitting in a giant office right now. So I'm going to show you as a simulation of what this would actually look like at scale. So we will add a sensor. Oh, and you see these blue dots. And this is actually, we'll make this a, oh yeah, so like just, for reference, like 10 feet's pretty high. When you get to 12, the field of view gets colossal. Everything I'm showing you is dynamic, meaning even if you're at 13 feet, we can confine artificially through software that is only measuring, say, this particular square. Just depends on, what you're looking to do. In fact, let's just go and discover more parts of what's being used. I'll add another sensor. Oh, there's another person. And we'll bump that up to 13 feet. Again, you can see someone who's sitting at this desk. We can go into a soft seating area, which I think is also often a common question. How often are people using this space? You'll notice that this also gives us a sense of how far away folks are. If I scroll down, each of these grids, these little dot grids, these gray squares, are are measurable for us. We actually know how in real life what that square represents from a distance standpoint or from a square footage standpoint. So if you want to figure out whether or not these two folks are too close, not that you're going to set off a blaring alarm, which I think is really bad marketing from a lot of technologies around social distancing, but like if you're trying to understand the safety of a space, not just the utilization of a space, but the safety of a space, we have an entire product called Density Safe, or Safe by Density, designed explicitly to help you keep your employees safe as you reopen. All right, this is kind of fun. I'm enjoying sort of like trying to find people. And you can see we can support, really, really small spaces or really large spaces. The other thing that I love is that, each of these show individual seating. So like, I'm not just measuring, I've got the sensor coverage, and this is what I mean by overlap. So you can overlap fields of view, and then you get this contiguous measurement as people move into and out of space. Is there any resolution degradation? So
Andrew, just to kind of add to that too, like this is all the live data set, and because we can sort of track how long each little area is actually occupied for, we can essentially add that up over time and present this as a heat map. So the darker areas, or we're not showing that here, but essentially the more each little area is used, we can really layer that on top of each other, and over time you would see sort of the hot spots in a level of precision that doesn't really exist at the moment. And that's another pain point that we've found a lot of. There are other perfectly viable solutions for sort of tracking this kind of use roughly, like in this general area, whereas we can sort of track it in this very specific sort of 2 by 2 foot area, essentially the width of a person.
And I think to one of the questions that was asked was, could you show the journey through a floor area or retail space? And the answer is, as long as you have contiguous coverage, the answer is yes. So like you would just add another sensor, say right here, and then you've got this contiguous perspective. And as people get up and move, just like I've been doing, which you can see me, you can see me moving. It would track my motion through that space. All right, there's a question about resolution degradation. Rob, do you want to speak to that? It's 8 feet versus 20 feet. How should people expect to deal with resolution or quality data?
It's a really good question. So, I mean, the best way to think of this is that it's sort of like a cone that juts out. It's a fairly wide field of view. That's how we get this really great coverage. Around the edges of any field of view, you'll get some degradation in signal. The signal is always strongest nearest the center, but all the field of view that we advertise is all the functional field of view. So obviously, we can push the boundaries, but in software, unless the results sort of lead to clarity in terms of, hey, there's probably a person there, we essentially shrink what the data sends up. So what you're seeing here is really what's being advertised and is representative of the the quality of data really across the entire field of view.
A couple questions. One was, can the focus be dynamic presets for non-fixed furniture layouts? This is all dynamic. It's possible to change at any time by simply logging into this tool. This tool, actual customers can have access to. This is also the tool that, that we use for setup and implementation. So you can actually see where all these devices go. You can see where people actually will be, and you can change it based on however your floor plan changes. I would say this concept, and there's another question about, is this easily changeable? The industry is moving to A/B testing physical space. How performant is this chair? How performant is this 9x9 space? And I wanted to show you one of the coolest things, and I didn't tell Rob I was going to do this. So if it doesn't work, it's Rob's fault. So this is sort of a new space. It's called Giraffe. Our engineers really love animals. What's cool is you can see 2 people in it. This is an occupied office. So this giant square shows that this conference room or X lab is occupied. Now, if I draw a box next to let's say this small team space, there's nobody in it, which you can tell because it's not filled in. Now, what's really cool is, well, I don't think there's anybody in it. Let me double check. Oh, there is somebody in it. Okay, well, you see, adding our sensors helps you understand whether or not there's humans in a space. If you were to imagine for a second that this sensor was not there, or it was there and nobody was in this space, it would show an empty state. Now, empty states are just as useful as occupied states. Counting 0 is incredibly useful because when you count 0, we can start to understand underutilized space. We can tell you where there's excess space. We can help you identify which leases you can avoid. We can help you identify which spaces you might want to move more employees into. You know, the goal isn't to just constantly sell off space. The goal is to identify where humans spend time, where they don't spend time, and then load balance the system so that people are happier and substantially more productive. So one of the really cool things about this is that because these are all digital artifacts, I can create a space in a space. I'm going to measure this chair. Let me just kind of zoom in a bit. And I want to measure this person, or this, not this person, but this, these lab spaces, or maybe these standing desks, we'll call them, I guess, standing desks. And as you can see, the empty states are ones without humans in them. And the filled states are the ones with humans in them. This has never been possible before. Now, I might be a little bit like exuberant because like we're the builders of this thing, but this has never been possible before, which means not only can I determine the effectiveness of this room, we can determine the effectiveness of each seat. And that is an extraordinary leap forward. Physical space is never going to be the same. Taken to its natural conclusion, physical space will never be the same. Okay.
I should also add an additional thing that's not necessarily being demonstrated there is you can actually group these things and expose in a summary level. Like if there are 4 seating areas within that that green space, I think that was tiger or rhino. You can say, hey, how many seats are available in tiger or rhino? So there'll be sort of more complex grouping functions, and the next level sort of beyond this is just how do you actually aggregate this data in a way that's simplified, and I'll get into that very briefly, but that's probably for another time.
Yeah, so I'm gonna keep going to some questions. I hope you all don't mind that these little blue dots just keep on keeping on. How is the field of view controlled? Oh yeah, I think I mentioned that one. This is all dynamic. If you move walls, we can move with you. If you update your floor plan, just update or replace the floor plan. We talked about excluding the third person in the demo. How do you achieve that? Can you speak more to exclusion capabilities? Yeah, so I'm not sure if this is specific to the question you're asking, but if this device is, this is a radar-based system, and a radar-based system is substantially more useful than an optical system. As you can see, it can actually see now, I know this is software, but it can actually see past areas that it may be interested in. And so when we talk about exclusion, all we're talking about is you can dynamically say, beyond this line, don't use any of this data, which is just that's purely software. All right. Let's see. What format plans can be uploaded? PDF works. I don't know about DWG, but PNGs. I mean, I think that the goal is really to support whatever your native format file is, or file format is. So we've even had CAD files that we've uploaded at some point. Really, we want to make it as easy as possible for you to visualize data inside your own space. Would the sensor be able to handle periods of high foot traffic going in and out? Is it able to compute an exact number of people in the area? Yeah. So as you look at me here, standing here and moving to the right and moving to the left and spending time on the couch, we track multiple people. We track multiple people inside of a single space. So it doesn't necessarily mean
Andrew, not to interrupt too, but I think the key word there is probably large amounts of foot traffic and likely areas that can actually hold large amounts of people, and that's where we think it's really beneficial to explore our entry sensor as well. In addition to this, you could totally flood your entire space with this, but depending on what types of analytics you're looking for, what your use cases are, it's the main reason why we have two distinct sensors. Our entry sensor would allow you to measure massive amounts of space with fewer sensors, so overall a more cost-effective solution, and still deliver a really accurate count of that space that it's containing, and also handle crazy transaction rates. So we typically use our entry sensors for things like cafeterias or lobbies to derive like a really accurate count and really accurate transactional data.
That's a really good point. So these doorways, let's say for instance you wanted to cover occupancy and use total number of people relative to square footage and capacity for the entire floor from the elevators. And let's say these are the only two entrances to this floor, this section. We're going to assume there's no stairs, no emergencies. You would put one entry sensor here and one entry sensor here from density, and we would turn all of this into analytics, so you'd understand how space is being used without the granularity of individual soft seating or individual desks or whatever else it might be. It'll be able to get you up and running very quickly on overall occupancy. Let's see. So we don't build the software. One of the questions has to do with like, do you have an application that allows you to see if the space is reserved or not reserved? We actually do have a product that will show overall availability of space. So it's called Safe, and it shows up on your displays or display, and it shows the relative occupancy across floors, spaces, buildings. This will be input into that display concept so that you can provide this data live to occupants in any form or fashion you may want. And if you have a mobile application or a tenant engagement application, like Host, for instance, with CB, or you work with a company like Robin or other IWMS systems, we are happy to integrate with those tools. To install the previous sensor, we had to provide door heights and widths. How do you implement or design this in open space? Yeah, so with this, like, it's substantially more visual. In fact, you will even see many of our entry deployments and implementation and planning use a tool like this to simplify a lot of that process. Entrances are a little bit different than open area. Open area, the constraint is predominantly software because you're creating artificial constraints as opposed to using the ones that are inside of a space. How accurate is the OA sensor?
There's also another question in there, Andrew, I think just sort of around that, which is like, will you be able to manage entry sensors in a similar tool? And the answer is yes. So our goal is to get entry sensors into a similar tool as well, again, to guide planning. While the configuration is slightly different, it's still extremely helpful to have the context of where sensors live. Just makes management a lot easier. And so you'll be able to manage all of your sensors together.
So we're gonna do rapid fire because we have 40 questions to get through. So let me, I'm gonna ask a question and we're just gonna try to get the absolute shortest answer. So let's see. Is there a limit to how many bounding instances, Rob?
How many bounding instances?
Yeah, so how many spaces? The person's asking how many spaces there may be available.
No, there's no limit. No, there is no limit. You can create an infinite amount of spaces. In terms of nesting spaces, like I think you'll run out of like a geographic limit. Like this might be too technical.
You're not following my rules. These are short answers. Okay, so
all right,
can this work? I'm going to ask more questions of you, so don't go anywhere. Can this work with supermarkets? If you wanted to get an email alert when there's more than 3 customers in line? The short answer to that is we have an entire product called alerts. So if you're trying to measure, the number of people in a space and you want an alert on a certain criteria, that's something that we natively support. Drifting, really good question about resetting counts and drifting. Now, drifting happens with entry counts because imagine for a moment you have a 99% accurate entry-based system. So you have people walking into and out of a space and it's 99.5% accurate. You have thousands of people go into and out of the space. That 0.5% inaccuracy, if you're measuring small spaces or large spaces, can result in drift. And what drift means is, let's say we miss an exit. Well, if we miss an exit, that means that there's a person, theoretically, still in the space. This project's code name was OB1, also known as Panda for some silly, stupid reason, but the code name for this project internally was actually OB1, and it was not a Star Wars reference. It referred to the off by one problem. And the off by one problem is this issue of drift. This is designed to never be wrong around occupancy, meaning if there is someone in a space, we ought to see them. Now, there are some circumstances that are edge cases. If you can somehow move, become like a perfect plant that doesn't move, or a stone wall that is not moving at all, like there are some like edge cases where we won't pick you up. But by and large, this solves the drift problem. At the end of the day, when everybody leaves, if there is nobody in space, we will count 0, which is literally what we've been trying to do for the last 2-3 years. It's like one of the hardest problems we've ever worked on, and we're incredibly proud of this particular accomplishment. So we have about we have another I'd say 5 minutes on the calendar. If you'd like to stay, we will keep going until right about the top of the hour. Let's see.
Andrew, can we buffer in a little bit of time just to show off some analytics and safe really quickly?
Yes, I'll make sure we've got 5 minutes at the end. Does that work? I just want to make sure we get through these questions.
Yeah, no problem. I think it'd just be helpful. There are some questions that I think, it'll help.
So why don't you take it and then go? I'm going to stop sharing.
Sure. Okay. Well, this will be quick, but I just wanted to show where this data lives. So we have a dashboard. It's fairly robust. We have this sort of general spaces view where you can see live count and just quickly browse, daily occupancy. We have our analytics application as well that allows you to create these sort of very custom reports super seamlessly. We have a couple like pre-canned reports that are really helpful as well. So this is where, like, if you had OB1 and entry sensors, you could really aggregate this data set. You can export it and integrate it into your own sort of data lakes or external reporting systems. You could also create dashboards that essentially you can email to people or present during a presentation with customized insights and more extensive reporting. And then we have our displays, which allows you to essentially create a list of displays. And this is what Andrew was mentioning earlier, where you can create these displays and it will expose how safe a location is in real time. And they look like this. So this is all demo data, but you can see that the status essentially changes from like wait to go. You can customize the text, you can customize a list of spaces. This is really kind of taking off for us at the moment. You can use it for bathrooms. You can use it for lobbies, for cafes, essentially using as a super lean wayfinding system. So really lots of awesome stuff, awesome use cases from Safe. Really encourage people to check that out. And then lastly, one thing I just quickly forgot is just the ability to set up alerts. So that's super easy as well. You can really create as many alerts as you like based on certain criteria, and it'll send you an SMS or push notification. We also have a mobile application that has a lot of the same functionality just kind of baked in, and it's super lean. So quick and dirty demo. If you're looking for something more robust, obviously reach out, and always down to go through it. So Andrew, I'll stop sharing. We can just go back into questions.
Yeah, that's great. Cool. You mentioned API integration. Is this device fully supported like our existing sensors? The answer, I'm gonna let Rob answer that question. It's mostly just are there differences between one API and another?
Yeah, no, all the same API. So our API is really the foundation of everything that we do. So all this data will be accessible in our existing API. There'll be new endpoints for it. Most of those endpoints are available just undocumented right now. So yeah, we are consumers of our own API. So we always make sure that that's super top notch.
The system does support PoE for power and connectivity, or an outlet and Wi-Fi. Should you want to do a deployment that doesn't require you running a long cable to an IDF closet. Is it possible to push messages to, sorry, there's quite a few here. Yeah, so our mobile application actually does support native alerts. So if you have criteria that you want to get a push notification to, we can do that under whatever the criteria is that you're measuring. So number of people that are showing up. I think even we were working on a rate of entry at one point being a thing that we'd like to expose to customers. So how many people are actually showing up and how quickly. How do you reconcile when two or more sensor boundaries overlap? So it's all through software, and it's all based on this grid structure, which is really clever from our engineering team. And it allows us to essentially stitch together multiple fields of view without having to deal with what's called the handoff problem. You're talking about a really important problem, which is the handoff problem, where you have non-overlapping fields of view and you have to like guess who's showing up as they come through. In our case, if you overlap, it pretty much goes away. Let's see. Do we have an app for FM, like facilities management teams or end users? We do, both mobile and web, which is a full analytics system. Data bandwidth. Rob, do you want to specifically talk to the raw data and just how heavy is it on the network?
Yeah, totally. I always forget the numbers off the top of my head, but what's great about this particular data set is how small it is. So it's non-optical. So we're not sending up these images or video or streaming that at any point in time. If we send up data for our entry-based device, we do all the compute on the actual device, so we don't stream any of that. For this device, same deal. We're kind of doing any filtering we need to do on the device and just sending up that point cloud data you see, a little bit optimized. So super low data consumption for the most part, particularly with open area, given that, yeah, the data set is just small inherently.
There's another question from that one that had to do with latency. How fast is the thing, Rob? Also, you saw me moving, by the way. That's emblematic of me beneath the device live, and it going through our entire system, being associated with the account that this particular interface that we just showed you is, and using our API to render the output. So, it's extremely fast, but Rob can speak to specific latency.
Yeah, well, we obviously strive for real time. So we go for sub-second latency. On our entry sensor, we advertise 700 milliseconds, which it can be faster than that as well. So yeah, we take a big pride in our pipeline, spend a lot of time making sure that things are low latency. So it's super quick. Everything you saw Andrew do is all the real deal. That's how fast we can get data off the device onto a screen.
There's an important question around, do you need to know the exact X and Y coordinates of where the sensor is installed? And the short answer is no. All we need to know is on the floor plan that you have, we need one wall. We just need to know like what is the size of the wall so that we can properly associate the height of the installations that you're doing with the actual square footage of the floor plan that's representative.
Yeah, and Andrew,
sorry,
maybe
question,
just to tack onto that.
Oh, I'm sorry. Go ahead. Yeah.
Well, just to tack onto that. So it's certainly helpful, but we understand that there's always a difference between a floor plan versus reality. So the reality is the sensor doesn't necessarily have to rely on the real world. Like Andrew said, you need a super accurate reference measurement, and the rest just kind of takes care of itself. That being so, you might want to make slight adjustments to the central location to ensure it maps properly to a floor plan or a plan of reference. You could also just not do that at all. So it's extremely flexible. Like we always talk about a design principle internally where we try to make it really easy for people to fail, but also really easy for people to fix and learn. So we've really taken that to heart and designed the system accordingly. I'll also add, however, we do sort of display measurements relative to the floor plan that you provide that tend to be extremely helpful for installation reference. The reality is you want to estimate how many sensors you might need to cover an area. So we do display estimates of measurements that you can reference during installation to ensure you're properly covering your area.
There's an important question about price around cost per square foot. So we charge about $199 per device per year. There's a one-time hardware fee. All of our pricing is public, which you can see on our site. but we charge $199 per device per year for access to the data for everything I just showed you, which on a per square foot basis, you're gonna result in, depending on the height of the installation and the coverage per sensor, anywhere from 10 cents a square foot to 25 cents a square foot. But that really depends on just like how constrained or how high your ceilings are. The reality is, like, our end objective is to make it financially irresponsible not to measure how the space is used. So if you and that's the other really important point is we have something called price match on a coverage basis, which means if you find if you get a competing proposal for, say, 500 sensors or 1,000 sensors or 10,000 sensors or whatever, we will essentially guarantee being or match that price, that proposal price, if it's lower than ours. The goal is to make this like scalable for you. The reality is, on an installation basis, you should expect approximately a 60% reduction in overall install cost, or up to a 60% reduction in overall install cost, just because the number of sensors that are required to cover the same square footage is substantially lower. There is another important question just around like, when you're talking about sort of X and Y coordinates, one of the things that's really important about real-time systems is that we can actually, typically when you work with vendors, you provide a floor plan, they put a bunch of dots on floor plans, send the PDF back to you. This is actually something that we can do live together. It's something that you can do without us. It's something that we can do for you. It's also something that you can be sitting beneath a device, setting up an environment, all because you've got this real-time function. So to Rob's point about making it easy to make a mistake or make an adjustment or whatever, you don't need the exact XY coordinates. We can actually just show you where the hell you are inside of space, and you can make adjustments based on that. Let's see. Maximum number of metrics or zones per sensor. There is no maximum. You can measure as much as you'd like. As a percentage of the total project, what is density's effort to complete a project? We are responsible for providing the technology and helping facilitate the deployment. So we have a network of installers that you can work with. We also work with your preferred vendors. It totally depends on how you like to operate on physical deployment. But we are here to help you see all the way through to success, project success. Is your technology proprietary? It is, yes. This is not off the shelf that we've bought. This is a product that we've built. And I should also mention, everything that we just showed you, the device that Rob showed you, that's manufactured in the US, in a factory that we own and operate in upstate New York. We're immensely proud of that. It's actually, fun fact, we manufacture our products at a lower cost than Asia. A lot of our team came from Apple and a variety of other places. We spent a lot of time trying to figure out how to build a great product, and one of the key ingredients is actually building in the US. Does it follow the same pricing model? So there is a subscription. There is an ongoing cost to these systems. These systems actually get more accurate the longer you have them deployed. You get access to more analytics the longer they're deployed. You get better benchmarking data. One of the really interesting things that we're starting to see is trends across multiple industry deployments. So all of those things come with the price point. Let's see. Yeah, if you don't have staff to like analyze the data, we design systems that are intended to make it easy for you to consume and understand without needing to hire some outside consultant. If you want to work with an outside consultant, we love working with folks from the large real estate brokerage firms. We love working with folks that are interested in space design, architects, and so forth. But you don't need them in order to make use of the data. We're trying to make it as usable as possible for anyone. Can these be tied into SAFE? The answer is yes. Is there a handoff between the entry sensors and the open area product? Unique individuals. So we don't do uniques, meaning like Andrew or Rob, but the entry sensor and the open area sensor are designed to inform one another. So the data from entry will inform our understanding of open area and vice versa. But really, like, you can think of this as space. So we are taking entry and we're taking open area to provide a better understanding of your space. However, entry and open area can operate independently. You don't have to buy both in order to get the value of one. These questions are spectacular, and I'm sorry that it's taking me some time to get through them all. Open area is not designed for entry, meaning like you wouldn't install this version of open area above a point of entry to achieve entrances and exits. It's really designed for open area measurement. That's what our entry sensor
I should
is designed
add, you know, technically the technology, you know, it's possible, but we built such an amazing entry sensor. You know, it really makes a ton of sense to use what we've designed there.
Let's see. Yeah, so we also do support the question about capacity. We do support a percentage of capacity to create alerts. So if you have a capacity that you're trying to make sure you don't exceed, that's actually what our safe product is designed to do. You set a capacity, and if it starts to approach it, we can send you an alert. If it exceeds it, we can send you an escalation alert. This product is being used by, I don't know, roughly, I think something like 20% of our customer base, if not more. It's a really, if you have an existing deployment, you can actually just turn on the software. If you don't have an existing deployment, it comes bundled, safe comes bundled with the technology. When can you buy a unit? So we have limited availability for the rest of the year. You can buy them essentially very soon. So we're talking like days and weeks, not months to wait. For volume purchases, so if you're looking at thousands of units, hundreds of units, you know, that's a longer conversation, and large scale production will begin early 2021. So if you want to get the technology in hand and start playing with it, that's something that we can support in the near term. If you're looking for volume deployment, that's something that I would just ask you to reach out to our team, and we can walk you through timelines and when you might be working on a project. How much maintenance is required? Yeah, so if the product fails, our failure rate on our entry sensor, because we own our factory, is and it is of our own design, is I believe 0.65%, 0.65%, not greater than 1%. It's extremely small. Open area is a new product, and with any new product, it has its own measurement of failure and yield and so forth. But we expect a very high, yield and very low failure rate. If it does fail, we have a 5-year warranty. If it does fail, you just send it back to us and we give you a new one. So goal is really to make it as easy as possible. Let's see. We do have multi-year discounts, and we have term and volume discounts. So if you decide to buy for 5 years, 3 years, or if you decide to buy in large volume, just let us know and we discount. Also, a lot of this I think is available publicly on our site. Let's see. Details of the spec sheet, we'll provide spec sheets to come. You know, with any new release of a product, you want to make sure that you're as comprehensive as possible. So we'll be following up with that. How do you test accuracy? I would say, you know, walk underneath it, create some spaces, and wander around. It's really easy to determine whether or not the thing's working. You know, we're here to help you be successful. So we have customer success managers that get assigned to your account to make sure that you're getting stood up properly. Can a sensor push a notification to two people that are closer than 6 feet of distance? The short answer is technically yes. The longer answer is really just a question of the scalability of that. How often do you want that? What would that actually look like? We've talked about providing this in real time. I'd say the baseline infrastructure, distance between people, the ability to send out alerts or automated emails, that all exists. So it really is just kind of dependent on like what workflow does it kick off? Is it just notification? Is it roll-up data? You know, one of our recommendations to customers is to not put a blaring sound somewhere, you know, and say, you two are too close. It's a very, one, it's Big Brother, and number two, people are gonna either self-police or they're not gonna care. And they're just gonna stay really close. And I think it's incumbent on the workplace, the people that we work with, you know, believe that it's incumbent on the workplace to create a safe environment. But it is not to assume everyone is a child. You know, it's like they're either going to follow the guidelines or they're not going to follow the guidelines. If you are looking to try to understand 4 million square feet of space and how often social distancing guidelines are broken, that's something we can definitely help you with. Large scale roll-up analytics is something we can definitely help with. And if you want to put up an alarm, I guess we can do that. We just would encourage you not to. I think it's probably the only thing. Yes, 1 or 2 sensors is also viable. You don't have to buy hundreds in order to get started. A lot of our projects will begin with an initial deployment and then expand to a larger volume. So just feel free to ask. Sensor resolution. Rob, do you want to just quickly mention sensor resolution? And we have about 90 seconds.
Yeah, and I'm trying to answer as many as I can just via chat. Around sensor resolution, what exactly is the question for resolution? Are we looking at like how many square inches, like how accurate we are to the square inch? So I can answer that. At least what you're seeing there, each square essentially represents 6 inches. So I mean, we're basically as accurate as you can be in terms of how much space a human body takes up. If you chop me up into inches, kind of down to the inch. I hope that makes sense.
Yeah, it's a little bit morbid, but yes, it's really granular.
Yeah.
There's a question about excluding staff. This technology is not designed to specifically identify who is who inside of a space. There are some clever ways that you can put apps on staff's phones, for instance, that allow you to determine, who is nearby a Bluetooth beacon signal. I would say those are the types of things that we partner with, not something that we would provide natively.
Yeah, I'd also add like a great way to filter that out is if you know generally how many staff are in a particular location, it's very easy to just kind of filter that data set out. So that's what a lot of our customers do.
We are almost done with all the questions. Let's see. Two-dimensional floor plans. So I don't know if you're talking about like bunk beds. We don't do bunk beds. But someone has sort of a question about two-dimensional floor plans. I would say we can do spaces in spaces. So if desks or spaces inside of a flat, space. I guess this is this is two-dimensional floor plan measurement. If you're asking about three-dimensional floor plan measurement, we can't. That data is stuff that we can make available, but it's unless you've got some crazy ladder function, I don't know that we're going to be terribly relevant. And then all of this data is designed to be used by end occupants. So is the space busy? And also, so your employees and your people, as well as people that are managing the space. So we have large scale analytics, and then we also have really easy to use displays and interfaces. And then I think we got through almost all the questions. How many days, months of data will be kept for the dashboards and reports? There is no limit. We do have data retention policies. So if you decide you want it deleted after a certain, if you decide you don't want to work with us anymore, we can scrub and delete the data. And then I should also say
I think it's go time, Andrew.
Oh, I'm sorry. We're over. Okay. All right. I really appreciate all of you spending time with us this morning or afternoon. Thank you so much for the questions. This has been recorded, so we'll be able to provide a link for those that weren't able to attend. So if you have colleagues that you'd like to share it with, then our team will follow up. We will be doing, I think, another one of these at some point. I'm not sure exactly when, but really appreciate the participation. If you have any questions, please just send an email to contact@density.io. Hit us up on Twitter, or otherwise reach out in any one of the 100 ways there are to get in touch with us. Rob, thank you for doing the demo, and thanks everybody for coming.